Well, good day and welcome to episode 40 of The Driving Force presented by the Louisiana Transportation Research Center. My name is Todd Blunt. I'm joined today by my friend, colleague, and co-host, Garrett Wheat.
Good afternoon.
And we are really excited that you've chosen to join us. We're highlighting the trailblazing people and groundbreaking projects driving change in Louisiana transportation. For the past 40 years now, LTRC has merged the resources of state government and Louisiana universities to identify, develop, and implement new technologies that enhance critical aspects of our transportation system here in Louisiana and beyond. We are continuing today in the second episode of a mini-series with LTRC's own pavement and geotechnical research team, focusing in today's conversation on several highlights of what's happening right now on the geotechnical side of the house. So to help us do just that, we are excited to welcome a pair of guests to the show. Senior Geotechnical Research Engineer Nick Ferguson and Engineering Tech Consultant Chris Mertz, who is doing great hands-on work in LTRC's Soils Lab. So we'll step away for a bit before we jump into our discussion with Nick and Chris. Welcome back to The Driving Force. We are in part 2 of our series profiling LTRC's Pavement and Geotechnical Research Group with a particular focus today on geotech research. We are welcoming both Senior Research Engineer Nick Ferguson and Engineering Technician Consultant Chris Mertz to the show for the next few minutes. So welcome to both of you. I'd love for you to begin by introducing yourselves to our listeners, like where you're from originally, what's your education and or career background prior to your time at LTRC, and how long have you been here?
All right. Thanks, Todd. Thanks, Garrett. I'm Nick Ferguson. I'm the Geotech Research Engineer here at LTRC. I originally am from the North Shore, so I grew up in Slidell, Louisiana. I went to college at LSU, and I actually started as a mechanical engineering.
Okay.
Until I ran into a class called thermodynamics. So I switched to civil. So I took a liking to structure classes, drainage classes, as well as geotech classes. And then after I graduated, I took the fundamentals of engineering, the FE exam. Most people take it during school. I kind of waited a little later after. And then I applied for some positions, and I got lucky where I had a rotational engineer intern position here, and
cool.
Which was cool because I got to not only see LTRC, but I got to see the Mat Lab for a couple weeks. I went to headquarters and saw a few sections over there, and then a position opened up over here in 2017, by the way. I forgot to say that. And I got a permanent position in October 2017 here. And so I started working as an intern, and I worked my way up to engineer level 6 now.
Awesome. Chris, how about you, man?
I basically grew up in Central, and I moved to Watson probably 10 plus years ago now. And I started with DOTD in maintenance in 2010.
Okay.
And I was in maintenance, and then I was in the maintenance for 8 months, swapped to construction. I was in construction for 10 plus years, and then they had a position open over here, and I applied in 2021, and come to work at the lab started as an engineering tech 5. And been here ever since.
Cool. So you've been in the Soils Lab your whole time here at LTRC. Yeah. Cool.
And to sum it up, what do you tell people you do?
Make mud pies every day. That's the easy way to put in layman's terms. That's related to kids. We have all the kids that come through. They always like, they'll ask a bunch of different questions, or like, y'all ever make mud pies? Well, that's what I do every day.
Well, Nick, you, as mentioned, the manager of the geotechnical research efforts going on here at LTRC. What does that mean from a day-to-day perspective, and what kind of projects do you work on and get to oversee?
The official title is the Senior Geotechnical Research Engineer. The word senior kind of throws me off, and I've been looking for alternatives to it. But day-to-day, my job has been somewhat similar, but I took the responsibilities of actually officially overseeing the lab personnel, including Chris, and where I think we already built a good relationship and kind of made it as a team. beforehand, and not only hold meetings here at LTRC, but I actually have to interact more with headquarters. There's a geotech section over there, and continue to progress in the projects I've already had and about to complete, as well as acquire new ones from my predecessor and mentor, Gavin. So I think we'll talk about a couple coming up on this podcast, but just working on finishing this geophysical research, as well as working on asset management and data collecting for the state.
Chris, jumping back over to you. You mentioned just a moment ago that you lead our LTRC soils lab, playing in the dirt, making mud pies. Flesh that out a little bit more for us. Like, what is some of the work that you and your partners do there day to day, and like, how do those efforts support what Nick and the other researchers are doing on their ends? Like, how do y'all work together?
So being here is kind of like very diverse. We have everything from doing field work to doing a lot of lab stuff, to doing a lot of computer stuff, a lot of machine learning type stuff, and database stuff, as Nick said. We go in, we put a lot of instrumentation. We put instrumentation on the load transfer platform on the intercoastal bridge. We did another one down out our way in Livingston at French Settlement Bridge.
Yeah.
And like I said, like Nick said, we do the database projects. We have multiple ones I've been working on since I've been here for soil borings, and also too now we're getting into the asset management of keeping track of the culverts and it's soon to be retaining walls and other things like that. So we see a broad range of stuff.
Yeah, it sounds like the work is pretty diverse. So probably not a dull moment.
Yeah.
What does some of the field work look like?
Some of it can just be picking samples up. Some of it could be, we have an ER device that we got. We're going out and testing that in the different conditions, laying it out. It's not difficult, but it is labor intensive to run it. It's a 50-something foot of, 500 and something foot of cable we'll have to put out, and 54 pins we'll have to drive into the ground. That's pretty labor intensive, and I'm trying to think what else, some of the other stuff we do all kind of stuff. So
yeah, and I think that's something Chris and I have in common. We both love going out to the field work.
Yeah.
We are in the lab a lot, or I'm behind a computer writing research papers, but whenever we have a site visit that we get like a email sent to us, like what he mentioned, the electrical resistivity project. Someone wanted to check on a dam that was like 2 hours away from here, and so that took a lot of time of planning. But as when we could set up that meetup, I was excited to make a plan of attack and try to perform these field works as efficient as possible. But we both love being outside, and I want to ask Chris to do something that I wouldn't want to do.
Sure.
And so it is labor intensive, but I think we kind of have fun with it. It does kind of the heat kind of gets to us, but we also get a nice tan after. But we do enjoy those days. So there's very few of them, but yeah.
Yeah, like Nick said, whenever we know what we have to do and your task and you're working towards that task, everybody has their job, what they do.
Yeah.
And whenever I finish something, he's right behind doing whatever, and I could be setting up the unit.
Mm-hmm.
And as soon as I get the unit set up, he can start putting in whatever we're going to label it, the test, and it's got to run a series of pre-tests, the machine self-test it does before we actually start. So there's a bunch of little tasks that we all do. We all know those tasks, and once we have it all set up, and then it's pretty much relaxed after that.
Yeah.
It runs its thing, and then after that, we'll either be planning for the next test we're going to do or picking up for the day. So like I said, we all have our tasks. We know what we have to do.
Sure.
So,
Awesome. So, Nick, last episode, Gavin shared with us about this multi-phase geotechnical database project that's been going on for 20 plus years now. Can you tell us some of the contributions you've made to that during your time here at LTRC? along with anything else you might be working on currently or in the future.
Okay. So it is a pretty old project, it sounds like. But no, we kind of just started working on it. It's crazy to think that, something that started when I was learning geometry back in high school. So I just started reviewing the project after getting my position late last year. And from my understanding, we're just organizing data from years past to make it accessible for the public. Chris has already mentioned that he has been looking at, I think 15 boxes of boring logs to input it and make it digital for the public.
When you say boxes, you mean like physical boxes of paper logs that you're digitizing?
Some of them are from the 30s, some of them are from the
Gracious.
40s, some of them are 80s. It's
That's crazy.
It's insane the amount of raw data that is there. To our physical copies to turn into raw data we have that we can put on a database for this.
Yeah.
Well, you mentioned machine learning earlier. Are y'all like scanning them and getting?
So they're talking about getting set up to where they're going to be scanned in, and then possibly developing an AI to read them and import them into where they need to go.
Mm-hmm.
We haven't got that for yet. So that whenever I first started here, we had basically it was an Excel spreadsheet and a file where they had already scanned in a bunch of them. And whenever I first got here, I imported in and got it set up in open ground. It was around 2,300 soil borns, and now we've added several other databases that are coming in. Our people have set up that are like, hey, can y'all put this on open ground, or hey, can y'all do this?
Yeah.
And so word's getting out, and they're reaching out and hey, we need to get these on. So
The more people that use it, the more data they want there. The more data you put in, the more people that want
exactly,
to use
and
it.
it's kind of crazy. We started out with a map that you can see, and we have them all dotted. By if we can find a location for them, they'll be geo-referenced. And so we started out with a map. It had maybe 10 dots on it. Now it's completely covered. So it's crazy, like how much it's going. It is, but
That's awesome.
And it's only gonna get better. So.
Well, Chris, I don't know if you've already shared what you would characterize as this, but what would you say is like the most challenging aspect of you and your team's work in the lab, and maybe what's the most rewarding thing about what you do?
As far as a lab, that's not really too challenging. I like when we go out in the field. That's whenever we I mentioned earlier where we do the we went out and put the instrumentation in on the intercoastal bridge.
Yeah.
So a lot of times the students come to us and they have a plan, like I want to do this.
Okay.
And whenever we get out there, sometimes they're lost.
Yeah.
Things are a lot different in the field compared to on site, on a plan. So that's where I really like to come in. I help them set up, like, okay, we're going to run. They have an idea what they want to do. I'll sit down, like, no, we're going to run these wires with this, and then we'll run a lot of fish tape, bringing in the wires and wiring, and we'll have a cabinet set off to the side to where we'll run all of our instrumentation wires to, and try to prevent construction equipment from tearing it up and everything else, because all this has to be set in place before really heavy construction starts. They might do some base work, but whenever they start bringing up for the walls or whatever it is, per layer, so all that has to be in place. We did a lot of instrumentation. We had load settlement plates, we had SAAs, and then strain gauges on the wire on the mesh. So that took a lot. And then whenever we did, we had another project with one of our other students who recently graduated, Assam. He wanted to do these little micro piles.
Okay.
So we end up, he had a plan in his head what he wanted to do. So we went ahead and we built one here. So we took 21 foot of Schedule 40 pipe. I cut it in half. We cut out the ends just right and bent it, and I welded everything up and put a cap on it, and we went and installed it in one of our sites at ALF, and that was the first one just to test the theory if it would work or whatever, and worked great. So then we proceeded on. We built
50 more.
no, not 50. We did 6 more, I think it was,
Okay.
and so that's what. So like I said, that's another thing. Goes back to everything. We cut, welded, and fabricated them all here on site.
Cool.
And then went and installed them at different locations around. And the maintenance helped us out on a few locations. We couldn't have equipment up there, but it was good to have, be able to reach out to those people. Hey, I need this, and they were able to get it done for us.
I'm curious, you mentioned earlier, like you were putting this stuff out before construction comes. Are y'all watching numbers live as they're coming in? Or?
Sometimes I do, and then, but most of the time it'll kind of give it like rated like higher than it really is, because you got to think of all the materials put onto it, and then they're really focusing in on how much force is being applied on the concrete, how much is translating down through all the layers of base material to the sub base. Yeah. So, like I said, if they really watched it, then you'd see every time a dozer made a pass over it or whatever. Sure. So, some of these things, some of these the instruments, some of them are really small, and to factor in that, it's amazing. It really is.
Well, are there any other studies or recently completed projects, maybe something that's currently in progress that y'all would like to share or highlight for our listeners?
So we already mentioned it a little bit, but so we are currently and about to complete a 2-phase project of a synthesis that what started out as a synthesis, and then it got adapted to a field testing research on geophysical devices, and we got to invest in actually acquiring a device and see if there's a possible advancements to see if Louisiana soils could be compatible for this new technology, because a lot of other states with bedrock use these geophysical equipment where they perhaps use seismic waves to determine the soil mapping of the layer, but we don't have that. We just have these saturated clays, so it just kind of looks like muck when you look at it. But so
Interesting.
So part 1 of this was published in 2023, and so part 2 is what we're working on now, and hopefully it's going to be published. It will be published at the end of 2026, and ultimately we're recommending the device we mentioned before. It's an electrical resistivity device, which can examine the soils underneath for soil mapping, or we can find unknown features like drainage that we don't know about, or maybe something that's lodged in from years past. And then, and so what I like to tell my non-engineer friends, it's something that we could use like a doctor uses X-rays before performing surgery, because typical site investigations require up to $30,000 borings for each one. To map the site before you add a structure to it or a roadway. And so this device can come in before, we can map out 500-foot lines here and there, and save some money for the department, and provide assistance on where they should add certain borings and not just do significant number of
like
them.
overkill,
overkill,
and then
exactly.
great waste.
Yes, yep.
I would imagine Louisiana soil being drastically different from other states requires a completely different style of...
Yes, yep. So we have to do not only shallow but deep investigations as well, because we don't have bedrock that's like 60 foot deep into the ground like some other states. So,
well, we always like to highlight for our listeners like the real world impact of the work being done here at LTRC. So I want to ask, do either of you have a story of something you've done during your time here that you've seen like implemented in a positive way in the field? Love for you to take a minute to share about that, if so.
Yeah, there's been a number of projects, and I don't want some of them to go unnoticed. we completed a few projects on how to improve site preparation and investigation using tools, so new instrumentation, rather than using the conventional devices that are radioactive. I'm quoting my hands, but these are tedious devices that require classes and badges and paperwork, and so we're just trying to find alternatives that anyone can use and not just call that one person in the district, like, hey, whenever you're not busy, can you look at this area so we can lay a roadway. One of the projects was using this dynamic cone penetrometer, so it's a performance test, and we're just trying to test it as a compaction tool before someone can lay a roadway. And that's actually where I met Chris at, where I think it was Florida Boulevard project, and he was very receptive, and we got along great, and he provided assistance on that research paper. And then when he eventually interviewed here, it was just like a no-brainer for me. It was like, I want him on my team.
That's cool.
But then also we are currently working on this geotechnical asset management project that my supervisor started up, inventorying all the retaining walls across Louisiana. And I'm doing the phase 2 where I'm looking at culverts. And a quick thing behind that is road design and bridge design has these asset management sections, but geotechnical does not. And so this is a nationwide thing. There's been many presentations on it from the big Washington, D.C. conference, the Transportation Research Board. And so we're collecting this data and try to provide it for the public, and this is important to keep track of their civil structures to make sure they're up to code and checked, so we could be proactive rather than reactive if there should be, hopefully not a failure that comes. And then a fun real world thing is this culvert project that we're working on. One of my project review committee members, he actually received a U.S. DOT culvert grant in hopes of minimizing ecological and wildlife impact. So there is a funding opportunity for the National Culvert Removal and Replacement Restoration Competitive Grant, and the purpose of this was to improve and restore the fish passage for Andromeda's fish, which was a word I learned recently. And so this is fish that are born in freshwater, they go out to the ocean, and they come back into the freshwater to reproduce, and Louisiana has 2 of them that are very important for this grant, and that's the Gulf sturgeon and the Alabama shad. So their funding is actually helping us in a way to continue this research and keep it going.
One of my favorite projects that, besides the ER device, whenever I'm skeptical of some of this stuff, whenever we first sat down about it, and looked at it, and I was like, but actually we got to use it. And then I don't know if y'all watch Gold Rush or whatever the show.
I've seen it.
I love Gold Rush. Okay, I love the show. Anyway, so they actually had one that they used on the Gold Rush. It wasn't our specific brand we have, but it was one I started. They'd come on. I forgot what time, and I texted Nick. It must have been 11 o'clock at night. Like, hey, so you got HBO? I said, turn on this. And I told him exactly with the timestamp or wherever. Like, hey, this is our device. He's like, okay, yeah. So that type of stuff, after seeing it in the real world and actually using it and seeing it does have impact. And then one of our other students, like I mentioned before, Assam, whenever he was here, we did this other project with the piles, but he also did one where cut concrete piles, and they put a jack in between it on the structure that was going to be taken down. And they applied a load to it, and what they learned is, and we had some lab work to go with it as well, but once that pile is driven and the skin friction takes over, you have a reactivity between the soils around in that pile and almost turns the properties into like concrete around that pile. So if you drive, even though you drive, say, a pile now and compare it to a pile 50 years ago, the strength of the pile 50 years ago driven in the ground will never be less than the new pile. You know, it's always going to be way more. So one of his projects in theory was to basically go in, and if you're going to build a new bridge, don't demo the piles, leave them in place,
Okay.
redeck it basically. If you have to make it wider, okay, you can go ahead and add piles and pour a new cap to it. But if it goes through, the cost savings is going to be tremendous of not having, because we design everything we do 2 and 3 times over, and sometimes even higher with the safety factor. So with that being said, way more capacity than we need. So we go in and just go and build a whole new deck on top of a old foundation. It's perfectly good. So that would save the department a ton of money, you know.
It's crazy. Never would have thought that.
Never would have thought that. That's
Yeah, and
interesting.
it's pretty cool because we did. We had one little thing we did. We basically it's an aging process where I made some little concrete discs. I 3D printed some cylinders to fit our small direct shear machine we have, and then we applied load for it, and then with the soil in it, and then the concrete, applied a load to it, and then after it was like 100 days, we did it in like 7, 14, and we went on to 100 something days. The soil actually bonded to the concrete. It was once you see it and realize like, oh man, it really does make a difference. Like how much force it takes for soil just to shear against concrete. You know, it bonds so much to that concrete. It's pretty interesting.
As a tech enthusiast, it's pretty exciting to see you guys using tech to, quote, play in the dirt.
Oh yeah, I mean it's constantly changing every and that's the thing with construction. We're making everything better, and faster. You know, and it's always going to change. You know, it's so rapid. You know, and there's new products coming out. You know, all the time. So.
And I have to correct you. It'll go amiss if I didn't say, but as my mentor would say, is dirt is what's found in your vacuum cleaner. So we deal with soil.
Awesome. Well, thanks to both of you for coming out today and telling us and our listeners more about this is really interesting work that you and your team are doing every day, and it's benefiting the state, creating efficiencies, cost savings, time savings, safety benefits. But before we go, we want to do one other thing, have a bit of fun with you with a few final lightning round questions. Garrett is going to ask these, so don't think too hard. Just go.
So, Nick, you're up first.
Okay.
2 questions each, if that's right. We know you like trivia a lot, but you also are into board games and like unique board games. So, if that's the correct term, I guess we could use. Do you have 1 or 2 oddities or favorites you would like to share?
Yeah, I like a wide array of board games, the classics, but I guess one of the unique ones is I like this one that's called Planet, and you have these 4 blue spheres, and you have these like hexagonal pieces of different terrain, and you're building a world based on these cards that are of animals. And so you can build a forest terrain, a mountain terrain, and snow, ocean. And it's kind of fun because you're making your own world and see if you can have life in your little globe. And the funny part is holding this globe with magnets and making sure you don't like drop it and you have to start over.
So it's like 1950s Minecraft.
Yep.
Haven't heard of that one.
Yeah.
Planet.
And then, I recommend that one. And then also, if you want to destroy friendships, there's one called Resistance, and it's kind of like Mafia, where you have a blue team that's the Resistance, and then like a couple spies that are the red team. Everyone closes their eyes. The spies look up and acknowledge each other, and then you just try to go through 5 missions and trying to figure out who you can trust and who you cannot.
Is that like a new version of Mafia?
Yeah, it is. So, and I actually became better friends with a couple people over it, even though they, lied to me.
That's funny. All right, so you're also involved in like a bunch of intramural sports, ultimate frisbee, and you travel and stuff for that. And then you and your friends and family all like to travel. So without getting too specific in where, I guess I'll leave that up to you. Where was one of your favorite road trips you've taken, and like some of your favorite or unique things you've seen or done?
Almost anywhere out west. I've went to the Northeast a lot, and the city and the food is good, but it's just like out west, it's just beautiful out there. And the best part is like the in-betweens. Like, like flying is cool and all, but like if you can drive and if you can get past Texas.
If you can get past Texas.
If you get past Texas, just driving to national parks. Like my favorite area specifically is North Arizona and South Utah, where we're just driving to Zion National Park and Bryce Canyon. But before then, it was just like everything was breathtaking, and I can't wait to go back. It's so worth it over there.
It's a nice area.
I mean, your nose kind of takes a hit with the dryness. But yeah.
Cool. Well, thank you. Chris, you already mentioned 3D printing a little bit. You do that for a hobby as much as doing some stuff for work up here. What's some of your favorite or most impressive creations you've done, even if you want to share one you most recently did?
Yeah, I did a 3D printed a kettlebell speaker. It was just a file I found online. It looked pretty cool, and it was basically a amplified 6.5-inch speaker, kind of like similar to a turtle box type thing, but it basically just round with a handle on it, and it was awesome. It's pretty loud for what it is, and it was just fun building it. Kind of 3D printing and electronics. And
How long does a project like that take typically?
The print itself, the form took like 14 hours. And then, but putting it all together, and I put it together in like, 20, 30 minutes. It's,
I mean, he's welding, he's doing electronics.
That's impressive.
Yeah. We also know you're a big baseball guy, and at this point in your life, you're a baseball parent.
Yeah.
Travel ball a little bit. So can you share what you enjoy most about baseball? And then I guess as a bonus, what stress relief tip do you have for other sports parents?
The greatest moment was like when my son hit one over the fence. That was like the ultimate. That was his ultimate goal. And once he made it, and did it, it was awesome. That was like I said, probably until he graduates or whatever, if he makes it on the baseball team, whatever, hits one over there. But right now, that's like right now. And just 2 weekends ago, he hit a grand slam, bases loaded, hit one over the fence. So
that's awesome.
And seeing all his little buddies, run out and congratulating him and slapping him on the top of the helmet and everything else, that's where it's stressful, but at the same time, like I don't think I'd ever change it. Like being at the ballpark on the weekends, you don't get things done around the house, but you're not gonna have that much time with your kids. And then, like you said, once they, especially for baseball, if they don't make it to a high school team, once they hit 14, they're done and over with. And then you can live the rest of your life, But you meet some of the best people, best friends we have are baseball parents we've met.
Yeah.
And we just did. We picked up with another team for a World Series this past couple weeks in Lake Charles, and a bunch of kids that never played together out of 12 teams. They come out fourth. Never played. None of these kids never played together. Show up, play ball, and that was it. So stuff like that. That's never gonna change. It's always it's gonna be in his heart.
Yeah.
But
that's awesome. Well, appreciate you guys again. Thanks for taking some valuable time out of your schedules. I know y'all are busy to sit down with us for a few minutes. We always love getting to highlight the good things happening here at LTRC and how they're connecting to the lives, the everyday lives of people across Louisiana. And you guys are right in the middle of that. So thank you for the work you're doing. We'll take one more quick break, and we'll come back and close out our time together today. Well, that's all we have for you on episode 40 of The Driving Force, presented by the Louisiana Transportation Research Center. You can learn more about what's happening at LTRC on a daily basis by visiting us online at ltrc.la.gov or following us on social media through Facebook, X, LinkedIn, and YouTube. We encourage you to like, follow, and subscribe to each of those channels, and also to follow and subscribe to this show on your preferred podcasting platform that helps others find us. If you'd like to explore the great work being done by Nick, Chris, and their research partners, including a number of the group's recent publications, you can visit their page on our LTRC website, and we'll provide a link to that in today's show notes. On our next episode, this will be our third and final one of this series. We'll shift gears to explore LTRC's pavement research efforts by welcoming two more talented and hardworking researchers, pavement research manager Chiming Chen and Terrell Gorham from the Mobile Pavement Lab. Till then, we are your hosts, Garrett Wheat and Todd Blunt, and we thank you so much for joining us again today. Drive safely out there.